Get your reps in. So we have another neutralization reaction here between hydrochloric acid and sodium hydroxide. In this case, we have 50 milliliters, 50 mils of hydrochloric acid, and that's at a starting temperature of 22.5 degrees Celsius. And we're going to mix that with 50 milliliters of sodium hydroxide. Base solution at that same temperature in a calorimeter. And we're measuring the temperature of the surroundings, which is the water. This reaction is in aqueous solution, is happening in water, so the water is the surroundings. We don't need to know moles if we're not asked for molar quantities. We can disregard that. So Q is equal to, actually let's specify. All right, the heat of the surroundings is equal to mc delta T, which is also going to equal negative Q of the system. If we just flip the perspective, we get the system's perspective. If we flip the sign, plug and play, plug these numbers in. Now we have 50 milliliters added to 50 milliliters. We have a volume of 100 milliliters of this solution. If you're not given the density, most of this solution is water, so the density of water is really close to 1. We can just estimate it as 1 at these temperatures. Now, if you have like extreme temperatures, then they're going to have to give you the density. But if you have 100 milliliters, you can just say we have 100 grams. Or if they give you 100 cubic centimeters, which is the same volume as milliliters, then you can say we have 100 grams. The mass is 100 grams of solution. Specific heat, we're going to use water's specific heat because this is mostly water. The solution is 4.184 joules per gram degrees Celsius. And the change in temperature here is 26 minus 22.5 is 3.5 degrees Celsius. That sign is important, so make sure you do final temperature minus initial temperature. This looks oddly familiar. Looks like I feel like it's like the same answer as the last problem. All right, 1,464 joules. All the numbers we used have 3 sig figs, so let's take this to 3 sig figs. We can do that by moving the decimal over. Instead of doing scientific notation, we can move the decimal over 3 times to the left and just convert this to kilojoules. And then we won't have to worry about scientific notation. All right, because 1 kilojoule is equal to 1,000 joules, just dividing by 1,000. All right, we're not done because this is, again, the amount of heat the surroundings gain, the water gain. Okay, now the reaction, this is asking about the reaction. How much heat is released by the reaction? So this is an exothermic reaction. We just flip the sign, and now we flip the perspective. It's negative 1.46 kilojoules is the amount of heat lost, right? Which is also equal to change in enthalpy, by the way, because the pressure is constant. Anyway, this is your answer.